Hello everyone. My name is Lê Trung Hiếu and I'm currently a learner of the Machine Learning Foundations for Product Manager course in the Coursera this one. And right now, I just finished the wrap up of the model, the last model, model 6 of the course, and I have contributed to the core project. And in this core project is a peer grade assessment. So in this video, I would like to explain to everyone about my model training procedures and its results. Right here. At first, I would like to report my final model performance data. The root mean my primary output matrix is the root mean square error is the 3.200 megawatt, and in others additional outputs are EM, AE, and the error score also, especially about the square error score is the 96.4% about prediction rate. So I think it's a highly trustworthy. So about the model training procedures, I the guide it is the I do it according to the guideline of the projects. It's not right here. It's not right here. This is the 5 step, and I do it exactly as the 5 step, not here. So at first, step 1, the guideline is for the problem described in the project topics section above. Then determine what type of machine learning approach you need and select an appropriate output matrix to evaluate performance in according the task. So at first, I clear the target of the project, right? The target of the project is to build a model to predict the electrical energy output of the CCPP type. And the machine learning approach I choose either the regressions of the supervised machine learning because the target is to build a model to predict, right? And the primary output matrix I use is the root mean square error. The additional output matrix is the mean absolute errors and the square error score. The reasons I choose this primary RMSE is because I want to strictly avoid large unexpected gap between the predict and the actual record in the dataset. Next, I move to the test 2. In this test 2, I will determine which possible visual I might need to use and identify the different algorithms I might consider. And the features I use, that's based on the phases of the CCPP, which were not right here. They are not right in this link in the Wikipedia. I decide that all four ambient environment reading should be used other features. So, and right here the 4 features, and the first is the temperature, next is the exhaust vacuum, ambient pressure, and finally the relating humidity. And the machine learning algorithm I use it first is the most basic, the linear regression according to the teacher. The linear regression is always the first algorithm we should use because it's the most basic one, and based on the linear regression result we can choose to another algorithm to compare that. And next, the second algorithm I choose because I choose is the random forest regression because I think that they are just for features. So the random forest regression is the most suitable one. Step 3, I split my dataset into 80 hundreds if for the training and 20 hundred, 20% if for testing, 80% if for the testing. Because I use the static library of the Python, so I use the K4 cross validation for the most efficient. At step 4, and I choose the approach either to use the grid ray cross validation because it's already on the Python library, so I think it is possible to use one. In step 5, I evaluate the performance of my final model using the output matrix I defined earlier, right? So right now I will show you guys that this is the directory of my projects. This CCPP data is the dataset I got from the core projects, right here, the dataset. This train py .py files is the one that I use the pandas and the sklearn of the Python. This library is right, not right here. The panda library is for reading in and manipulating the data and creating my features and data array. And about the sklearn library is for listening my data, reading my model, and evaluate my model, right? So I use these two library here. So about this train file process, the step 1 is to load the data, not right here, data file name. Step 2, I extract the feature in the target. Step 3, I slip the data into train in the test set. Step 4, I run the cross validation tournament. And because I choose the linear regression in the random forest algorithm, right? So I add another step right here that there right here, step 5, selecting the mesh model because I choose the RMSE matrix in the my primary, so I use this matrix to consider which algorithm is the best for my model. And right after I run the train file, I got the result right here. About the about the performance report, and first about the RMSE. This one is say that I'm sorry. Let me take a quick look. About the RMSE error. It say that in my model I just got the 3.2 megawatt error. Is the not right? The reduction which was wrong. The MAE is just 2.3 megawatt and the square error score is up to 96.4%. That's my model is predicted correctly. It's just 3.6% that there's some noise or something that my model cannot calculate the predictions. And that's all. Thank you, guys.